In this video, I want to show you why you're most likely using rate limiters wrong and how to really get the most out of them. If you search up online how to rate limit your APIs or what even rate limiting is, you'll most definitely encounter countless articles and blog posts and videos telling you rate limiters are for preventing spam and abuse. As for the implementation itself, it'll tell you to rate limit based on the IP, so IP throttling your API. Now, these suggestions are not entirely erroneous. However, most of the time, you won't really need this type of rate limiting. Don't get me wrong, in terms of preventing spam and abuse, that's something you obviously need to enforce. But IP throttling for your API? That should be managed by your web application firewall, also known as WAF. And that's not something that you should handle in your application code. But the point of this video is you should have a rate limiter set up that allows you to have that fine-grained control. So depending on the resource, you impose different rules. Now, what do I mean by this? Well, take ChatGPT for example. If you have the Pro plan, which lets you access GPT-4, you may have noticed that you can only send up to 40 messages per hour or so. So they are limiting you access to the resource, which in this case is GPT-4. Now, this kind of rate limiting should live in your application code, as they are tightly coupled, but it really doesn't make sense to have IP throttles in your application code, so it's a separation of concerns. They should live in your application code, and well, these will most likely be in your web application firewall. But how does OpenAI achieve this? Well, for that, before showing you the solution, I have this demo application. Here we can create groups, so we can say ASD, create, and as we can see, we get this group, we can invite members, and we can also delete a group. But let's say you're part of a free plan, so you can only create 5 groups per day. So if I come here, I can essentially abuse this API and the access to this resource that allows me to create a group to essentially have unlimited groups. And that's something you obviously do not want. What if the resource the user is accessing is quite demanding? Maybe it takes up a lot of computation power, such as GPT-4, so this is the perfect example. GPT-4 is extremely expensive to run, so they do not want anyone to spam their server and request over 1 million GPT-4 messages. That would blow up their servers and everything would crash. So for this, I created this rate limiter. Now I'm using tRPC, but obviously this applies to any server. So I have a window type, so we can say seconds, minutes, hours, days, and weeks. And then we have the configuration for the rate limiting. So we have the maximum requests a user can make. So this is of type number. Then we have per, which is a tuple. So the first number is the occurrence of this window type, and then the window type itself. Now, the reason why I'm using a tuple is just for ergonomics and that developer experience. So it is very intuitive because you can say 25 maximum requests per 4 minutes. So as we can see, it is very natural. But of course, this could be separated into their own properties. Then we have the unique ID. In a bit, I'm going to show you why this is important. And then unenabled. And this is for that conditional rate limiting. So maybe you want to enable this rate limiter based on a specific condition. And then we have the function convert to seconds, returns a number, takes in the amount and the type. And then we have the simple switch statement. Now you can find all of this code in the repository, so make sure to check it out. We then have the actual logic for the rate limiting function. So this takes in the session, so the user session, that's so we can restrict access to the resources depending on that session. So even if someone tried spoofing their IP address or whatever, it doesn't matter because they must be logged in to access that resource, and the only way to circumvent that is, well, to ultimately create new accounts. But you could also impose some security there. And then we have the arguments. So we check if it's not enabled, well, this function will not do anything whatsoever. But if it is enabled, then we get access to the window and then the window type. So these two from the tuple. We also create the key, so this will be stored in Redis, and in a moment I'll show you why this is the case. So we have rate limit, then the unique ID that we pass in. So you can limit access to the GPT-4 model, so you could add that here. And then the session.user.id, so we pass in the ID of the user. That way, doesn't matter where they log from. If they're using this particular account, they will be rate limited across all of their sessions. And well, we just use satisfies to make sure that we do not accidentally modify this template string. And then we get the current, so we say redis.increment and we pass in the key. And this is going to give us the current value that is stored in Redis, so key value per. Then we get the window in seconds, we pass in the window and then the window type. And then we check if current is equal to 1. So is this the first time the user is hitting this resource? If so, then let's set redis.expire and then the window in seconds. And then we have if current is greater than args.maxRequests, then we know that the user has exceeded the limit. So we can say too many requests. And that's pretty much it. Now the reason why I'm using Redis is because of this. So let's say you have a horizontally scaled system. So you have a lot of servers with the same underlying code and logic. Because if you only have one server and your application grew, then you need to have more servers so that you can evenly distribute the workload among all of them and everything is okay. So for this, you'd have a web application firewall set in place. So this could help with that IP rate limiting just as an extra measure. Then you'd have a load balancer, which again is going to evenly distribute the workload, so the requests to the different servers, and then the servers access the same database and the same Redis cache. Now the reason why we're using Redis is because if we have this system like this, so horizontally scaled, and you handle the rate limiting per instance, so specific to that instance, then what if the load balancer directs the request to another server? Now the rate limiting is out of sync. And so now each one has their own rate limiting configuration for each session. So to avoid that altogether, you can just centralize this within a Redis cache, and all of them access the same one, so you prevent that issue altogether. Now, aside from this, what if you're running in a serverless environment? Maybe you're using Vercel to host your Next.js application. Well, for that, you'd still need to use Redis. You cannot use an in-memory rate limiter, since it is going to be reset anyway. But obviously you can refactor this logic to use an in-memory solution if you're not running in a serverless environment or your system is not horizontally scaled. Now, as for how we can use this rate limiter function, well, for that, since I'm using tRPC, I have this middleware set up, so enforce user is authenticated, and then I have some checks here, so check the validity of the session token and whatnot, and this is just going to call options.next, and we pass in the context. So if you've used tRPC before, you should know how this works. But then I have this protected procedure, so we can say t.procedure.use, and then I pass in this middleware. So we make sure that this can only be used by authenticated users. But then I created this procedure, so protected rate limited. And this is the one that we use for that fine-grained control over what we want to rate limit for a particular resource. Now this takes in the config or a function. So we take in the config. So we have max requests per, and then this is the tuple, unique ID, and enabled. But remember that I told you that we have this enabled flag, and we want to enable it if a condition is met. Perhaps we want to do a preliminary check if we want to rate limit based on that condition that I told you. Well, for that, if we just passed in the subject, then we cannot really use this enable flag for any condition. So that's why we can pass in a function that passes in that session and then returns the rate limit config. Or we can pass in a callback function that takes in the session but returns a promise. So if we want to check the database, we can await and do whatever we want in there. So here all I do is return protected procedure.use. So this is for the middleware. We take in the options, then we have the config, and then we do a simple check. If the config is of type function, then we invoke it and we get the result. But then we check if result is instance of promise, then config is equal to await result. Because we know that this can be either the rate limit config or a promise of the rate limit config. And then otherwise, if it's not a promise, we just assign the config to result. As simple as that. And well, if it's not a function either, we just set the config to the one that we passed in. And then we call await rate limit, we pass in the session, and then we pass in the config. So we're constructing the configuration here with these callbacks. And then we just call the next function and we pass in the options. So this way, we can say protected rate limited procedure, and we can pass in a callback function, and we get access to the session. So maybe you could say enabled if session.user.email is equal to some email.com. Or you could perform a database check here, so you can await something, so you can mark this as asynchronous, well, whatever you want here. And then you get access to the actual procedure. So you can say .input or .query, .mutation, again, whatever. This is just so that we can get this fine-grained control. So maybe we want to return different conditions based on the free and the pro plan. So here you could check if session.user.plan is equal to premium, then you could say max 100, otherwise just 10. So this allows you this flexibility. So let's see this in action, shall we? So let's come here to groups.router, and here we have all of the procedures. So we have create, delete, undo, delete. So this is for the soft delete, where you can come here and delete one, and then you get this toast with the undo button, and then you can undo this. So if you're interested in that, I have a video for that, so go check it out. And then we have the get all groups. This is a query. So let's say we want to limit the creation of groups. So for that, we can say protected rate limited procedure. And then here we can pass in either the callback functions or, well, just an object. So we can say enable to be true, then max requests. Let's do 2 for this test. Let's be quite restrictive here. And then we can say per 1 minute. And then the unique ID, we can say create group. So this applies for only this procedure and only, well, for that session. And if I save this and then come back here, let's create 1, created successfully, then 2, we get created successfully. And what about the third time? Rate limit exceeded. And well, we can spam this, but nothing is going to happen anyway. And in fact, if I come here to my Redis cache, and then look up the rate limit. So we should have this one, rate limit, create group, and then we have the ID of the group. Now if I make this smaller and then spam this button, as we can see, and refresh this, so here we get 15. So this is being successfully rate limited. Now I actually made a little change, and that's because, well, this is a proof of concept. You can devise the algorithm better, and in fact this is a fixed window, not a sliding window. We'll see that in a moment. But what I changed was, instead of incrementing the value right away per each request, I check the value first. So current number await Redis.get, and then I check if the current is greater than the max requests. That way we avoid altogether incrementing the value if it's, well, unnecessary. So now if I come here, this key should be expired, as we can see, because the minute has passed. But if I come here and then create another one and then create this, so let's try 1, 2, and then 3 times. With the previous implementation, we should have the value for 3, but in this case, it should be 2 because, well, that's the limit. And as we can see, the time limit is correctly added. And even if we hit this endpoint, well, it's not going to be reset because that wouldn't make sense. So let's take a look at what I mean with a fixed window versus a sliding window. So our current algorithm, which is very basic, uses the fixed window approach. So we have this rate limit window, we get a request, we check the request count, and then we have this if. So within limit, if not, then we block the request, we could log the block, and then that's the end of the program. But if it is within the limit, then we allow the request, we increment the request count, and then we log the request. As simple as that. So all we're doing is basing it off this count. But there's a problem with this approach. And that is, since it is a fixed window, then the user doesn't matter when they make the request, since with the first request, that's when the rate limit will be initiated. So what I mean by this is, let's say we have this here. So we have max requests, and this is 50, and then we have per, and then we have 1 per minute, basically. So if we have the time window, so we start from 0 up to the minute, so 60 seconds, the user can make a request. So this starts. So makes request. Now as the time progresses, the user can make another request. And so they are now here, for example, and they have made 4 requests in all of this time. So we're at the half of the time. So this is 30 seconds basically. And the user has made 4 requests in this time span. Now the time progresses, and then we're right about finishing this time window, and the user made a total of 8 requests in all of this time window, but the maximum is 50. So the user can theoretically wait until the 59, make the remaining requests, and then once this gets reset, so we go back to 0, the user can make the other 50. So theoretically speaking, a user can abuse this in such a way that they can make 49 plus 50 requests in less than a minute, if that makes sense. Obviously not taking into account the first request that initiates the rate limit process. So this is the problem with using a fixed window. So what is the solution here? Well, for that we have a sliding window, and as the name suggests, it slides with the time. So we have the start, then we get the current timestamp, and then we check the request queue. So the current timestamp is for now, as in new date, that gets you the current time. Then we check a queue, so we have a queue. We know that a queue is a data structure that stores the items in the order they arrive. So here we would store the timestamps, perhaps other relevant information, but most of the times it's just going to be a queue of timestamps. And we check if it's empty. If it is empty, then we add the request to the queue. So here we would add the timestamp of the request, and then we check the queue size, and then we check if it's within the limit. If so, allow the request. If not, block the request. But let's go back and let's say the queue is not empty. So this is not the first request within that time window. Then we remove the expired requests. So we go over all of the expired ones where the time has already passed. So in short, whenever a new request arrives, we get the current timestamp and the request is added to the end of the queue, in layman's terms. Now, before adding the request, we check the queue for any of the expired requests, and they are removed from the front of the queue. And then after adding the request, then we have a new queue size, and then we check that against the limit. So if the queue size is within the limit, then we can allow the request. If not, we block it. So with this sliding window, we avoid this issue altogether, since it is going to be sliding with the time. So if we were to have this for 2 minutes, and then every time the user makes a request, this is now going to invalidate the previous ones. So the timestamps that are greater than the time that you defined in the rate limit. So if this were to be 2 minutes instead of 60 seconds, so 2 minutes, then here we could have another one for 1.5 minutes. Now this one will only be considered in relation to the other ones that are valid. Since this is 30 seconds, that means that more than 1 minute has passed, then this one would be invalidated and not considered for the rate limiting. So this allows you to have this max request to be 50 for literally every minute. Doesn't matter when the process was initiated. Now this would be a great learning experience, so if you want, you can try it out on your own. Although I believe there are countless libraries for this, or even just pseudocode, so that you can easily implement this with whatever solution you're using, whether it's Redis or in memory. Anyway, this wraps up the video. If you want to see more content like this, don't forget to like the video and subscribe. I'll see you in the next one.